Today I want us to consider the cells of the nervous system, the types of cells we have in the nervous system. So it will be under the terms, because let's look at some terms. So terms. By the end of this lesson, you should be able to tell me very clear differences between the following. The first one is a neuron. Again, you should be able to tell me what is referred to as a glial cell or neuroglial cell. Let me say a glial cell. You should also be able to differentiate between gray matter and white matter. So gray matter and white matter. You should have a broad and general idea about nerves. Because nerves are, what does it mean? Because nerves are, and then you should have an idea. Because ganglion, then you should have an idea. Because nucleus, you should have an idea. Now note, in terms of the central nervous system, or let me say in nervous system, making mention of nucleus, I know you have an idea of nucleus, the one which is the cell that houses the chromosomes. At this point, in America, it has a nervous system nucleus is something different altogether. You should also have an idea about what we refer to as a cortex. It's a differences between the following. It will be a blend of Tree and English. You should have an idea about all these, right? Excellent. Now, we know the nervous system. Nervous system. Now, if the nervous system now, there were two types of cells. Nervous system, there were two types of cells. There was the true functional cell, and there was the supporting cell. Right? There was the true functional cell. And there was the supporting cell. And the nervous system, talking about the true functional cell, from neuron. So we can see neurons are a collection of these neurons, right? Yes. Me friend neuron. Me say friend the for and one nerve cell. A neuron and a nerve cell. And now conducting cell, the same thing. Conducting cell. Identity because of conducting action potential. Conducting cell. And now communication cables. And they are the true functional cells. The true functional cells. The true functional cells. The point I want to establish here is that we have two main types of cells in the nervous system. And I make sure that the very first one, the neuron. And now one neuron. Now it's a nerve cell. It is the same thing. One nerve cell. Now it's a conducting cell. It is the same thing. One conducting cell. Now it's about communicating cables. And now communication cables are the same thing. Now, the true functional cells, because they conduct the action potential, which I'll let you know in the course of the lesson. Now, number one, what is the other type of cell? The other type of cell, the glial cell or the neuroglia into neuroglial cells. One thing neuroglial cells, not the glial cells are the same thing. Glial cells. One thing glial cells, not the supporting cells. Supporting cells. The same thing. Supporting cells. Right? Yes. We have two main types of cells. Two cells. The first one is the neuron, and the second one is the glial cells. Right? And act as connective tissues. They act as connective tissues. They are not the true functional cells. They are the supporting cells. So they are cells that support the neuron. So they act as connective tissues to the CNS, the nervous system. Right? And then talking about this neuron or the nerve cell, you'll see it very soon in the diagram. But first what you says, we have two types of cells in the nervous system. The very first one is the neuron. Now, I will say who these basics, because we're on these basics now. Talking about the nervous system, you go deep. You're talking about diencephalon, talking about supracorticulus and all that, talking about all this, the idea. I will say you have these terms, fingertips. Somebody can sit your mouth. We see two types of cells. The very first one is called the neuron, and now say the nerve cell, right? And now conducting cell, because they conduct as potential. They send information to each other, right? And now they are called communication cables. And they are the true functional cells. The next type of cell is the glial cell or the neuroglia. They are the supporting cells. They support the true functional cells. How many types of cells do we have in the system? 1, the neuron. 2, the glial cells. Isn't it? Good. Now, let's look at the neuron. If a neuron, we are go deep. If a neuron, we are looking at the difference between gray matter, white matter, nerve, ganglia, and all that. Then I think that'll be all for this very lesson. So let's look. All right. So let's look at the neuron. The neuron. So neuron. That is the true functional cell, right? Yes. And one your friend is saying the nerve cell. The nerve cell. And one from the conducting cell. Now I have a structure. I ain't too much detail. Now I have for a true nerve cell, for a true neuron, it should have a long process called the axon. Are you okay? Yeah. So again, we have a kind of axon. America have a kind of axon. Now, me I'm saying American, I'm saying chunk of kind of axon. And see, it should have a long process called the axon for a true nerve cell, and it should have the axon terminal, right? The terminal. Okay. Yeah. And then it should have a soma. A soma. And see, I'm gonna say, okay, let me do this way. Yeah. So this is the dendrites, not acute don't scale. Yes. So this is a neuron or a nerve cell or conducting cell, right? And for the axon, it is having myelin sheaths over there. So they are myelinated, okay? They are myelinated in a way. Right? So these are the myelin sheaths. Are you okay? Now, in between the, realize that here, there is something like that. This is first as the node of Ranvian. The node of Ranvian. Are you okay? And this is the axon terminal. Right. This is the soma, the cell body. Right? This is the soma. So man, you have no friend, and that's cell body. Cell body. And I must say, for a true nerve cell, it's having a long process. Your friend on the axon. It from here. Air columns here, the axon. Until we have cell body, the nucleus, right? The nucleus. And this is the dendrite. The dendrite actually increases the surface area because at a point in time, this neuron will be talking about so many neurons bringing information to this very one. So the point is the dendrite increases the surface area to receive information from other neurons. So some of the neurons will bring information, unless we'll get to this point, unless we come straight. The dendrite increases the surface area to receive information from other neurons. Now the point I want to establish is that I want to give you a clear difference between gray matter, white matter, nerve, ganglia, and all that. So for a neuron, for a true functional cell, for communication cables, note that they are having a long process called the axon, and they are having the cell body over here. So a group of this, you should have an idea, and then you have a cell body too over here. So note it for me. In the senka veno senka oye owa anka owono nitini, right? And then the tail ni. In the head no will become the cell body, and then the tail become what? The axon. So this is a neuron. I'm not going much into detail. We have axon hillock, main core, and brain. But the point I want to establish underneath nerve cell and say, I want you to have an idea about the axon, say the long process of a neuron, and then there's having a cell body over here. From the cell body, having extensions called the dendrite. That increases the surface area, right? But the point is not to say you have a cell body and your axon. I need this also way because to understand gray matter, white matter, nuclear, and all that nerves, I will say we have an idea about this. And say him share crown, and him say for every nerve cell or for every neuron, every conducting cell, we are having a long process known as the axon, and they are having its cell body, right? Exactly. Now let's look at the CNS, central nervous system. What do I mean by CNS? Central nervous system. Because the central nervous system, it is made up of the brain and the spinal cord only. The brain and the spinal cord only. Right? So the brain, right? So this is the spinal cord. And the brain too is on here. So this is the brain and this is the spinal cord. In combination, brain and the central nervous system. Central nervous system. And to say you say you're a neuron. A neuron so yeah, you're the cell body, right? And you're the long process known as the axon. And that's with the extension being our dendrite. Great. Now let's look at the difference between a nerve, tract, gray matter, white matter. Okay. Nice. Now group or a collection of the axons inside the central nervous system. Listen, a group of the axons found inside the central nervous system, you find a tract, and a group of axons found outside the central nervous system, you find a nerve. Again, group of axons found inside the central nervous system is called tracts, and a group of axons you know outside the central nervous system, your friend nerve. Into this is my central nervous system, my brain and my spinal cord. And a medical teacher will say we have this to be, if I say my axon, right? This is my soma, right? Now, I am a cell body. I am a cell body. And I also come here. I am axon. And a nature will say axon bebree ka bebree a na say you know inside the central nervous system your friend of tracts na say you sa axon bebree a collection of them outside the central nervous system your friend nerve. And this is how it will look like. So I have a one, right? So working in here inside the central nervous system. So these are the axons, and that's good. The axons found inside the central nervous system. But since a group of the axons found inside the central nervous system, I refer to this bundle of axons here as tracts, not nerve, as tracts. 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 But these axons, this long process, a group of them outside the central nervous system, they are referred to them as nerves. If they are found here outside the central nervous system, I refer to this bundle of axons here as what? As nerves. As nerves. Now, difference between tracts and nerves. Nerves are a group of axons, a collection of axons found outside the central nervous system. Tracts, group of axons found inside the central nervous system. Simple as that. What are the axons? Axons are the long process of what? Of a neuron, a nerve cell. See, group of axons found outside the central nervous system is referred to as nerves. Group of axons found within the central nervous system is referred to as tracts. Now we have the definition for nerve, and we've now gotten that of tracts, right? Excellent. Excellent. Let's look at gray matter and white matter. In gray matter, in white matter, and also now the same kind of the nerve cell. With my dendrites to increase the surface area. Okay, I have say my myelin sheet over here. Now I know this is what my axon. Yes, sir. My axon. I know this to be my cell body. Alright, so a long process here, axon and the cell body here, right? The nucleus inside. The soma or the cell body, same thing. So for every neuron, I have my axon, I have my cell body, right? Now, what is gray matter and what is white matter? Now, a collection of the axons, a group of the axons, a collection of the axons is what is referred to as, or a group of the axons, and your friend, the white matter. Group of the axons, like won't be a collection of them, and they're from white matter. I don't think it's difficult. Gray matter, a collection of cell body baby, a can't boom and yenya gray matter. And then nerves there, a collection of the axons no, outside the central nervous system, and their friend nerves. A collection of the axons inside the central nervous system, and they refer to them as what? As tracts. So we have ascending tract and descending tract. Tract that are sending information upwards and tracts that are sending information downwards, ascending and descending tracts. And I'm saying gray matter here, a collection of cell body, right, and from gray matter. A collection of the white axons and from white matter. Simple as that. Now, share nucleus and a cortex. Nucleus and a cortex. Now, the point here is that when we say nucleus, Obia Jimmy and say, oh, a nucleus is that is in a cell that houses the chromosomes. No. Talking about the nervous system, talking about the brain and nucleus, and for our brain, fine, we have it there, like some of the nerve cell, we have its nucleus, but nucleus, talking about basal nuclei, that nuclei, is something different altogether. The point I want to establish here is that talking about the nucleus now is something different. I say you need to know. And the cortex and also now what is the difference? Now, do you know the central nervous system as we explained earlier? So we have the brain and the spinal cord being the central nervous system. So the CNS, central nervous system, right? So we have the brain, right, to be like this, and then the spinal cord here, right? Now, group of the cell bodies found superficially and a friend of the cortex, and a group of the cell bodies found within the nervous system, central nervous system, surrounded by axons and a friend the nuclei. It's a group of cell bodies, right? Right. This is the central nervous system. We have the brain and we have the spinal cord. We want to know a very clear distinction between nucleus and cortex. This is a nerve cell, or a neuron, a conducting cell, or communication cable having a long process here known as axon. Now, a group of the cell bodies, here found superficially and a friend the cortex. It's a group of the cell bodies here found superficially, right, on the surface of the brain, and a friend is saying the cortex, right? And then group of the cell bodies embedded inside the central nervous system, surrounded by white matter or axons, and a friend what is called the nucleus. Fine, I have pieces of gray matter, or let me say pieces of the cell body inside here, piece of the cell body here, surrounded. They should be surrounded by the axons, and your friend is saying, your friend in the nucleus. And this is not the nucleus in the cell, but this is something different altogether. And before you understand nerves, nucleus, cortex, ganglion, and all that, you should be able to appreciate the fact that we have these things about the cell bodies here, group of them found superficially, and a friend on the cortex. Group of the cell bodies here embedded inside the central nervous system, surrounded by white matter or surrounded by axons, and a friend the nucleus. And I believe it's very something simple to understand. What about ganglion? Group of axons found outside the central nervous system. Group of cell bodies found outside the central nervous system, and a from the ganglion. Now, group of cell bodies found superficially inside, but superficial part of the brain is referred to as the cortex. Group of cell bodies or piece of gray matter embedded inside the central nervous system, surrounded by white matter or axons, and a friend the nucleus. Piece of gray matter or piece of cell bodies, collection of cell bodies found outside the central nervous system, and a friend the ganglion. Group of axons found outside the central nervous system, a friend the nerve. Group of axons found inside the central nervous system is referred to as tracts. And some of the tracts are going upwards, others are coming downwards. Those going upwards are referred to as ascending tracts. Those coming downwards are referred to as descending tracts. So it's a very clear distinction between nerves, ganglion, nucleus, cortex, and all that. In the very next video, we'll be talking about the nervous system components, the central nervous system, the peripheral nervous system, the motor, the sensory. We go to general sensory, and we go to special sensory, and then we go down, and then we dive deep into the integrity of the whole aspect. Thank you.